geography lesson. We're covering Theme 5, Element 3, Atmospheric Circulation. So take off your coat, tuck in that shirt. I'm Mr. S and I'll be your 5-minute teacher. Today we're looking at the basics of our weather. Why do some places get hotter than others, and why do we have entire regions of desert or snow? Well, it all starts with the sun. We've got a picture of our planet here, and this arrow, this block, is representing our insolation, which we know means solar radiation, incoming light from the sun. Around the equator is where we're going to get the most concentrated and direct insolation. So this is the area, the ground, that's going to get the warmest. We know that air that heats up becomes less dense. It starts to expand. And this is an area that we call low pressure. So less dense air, the warm air, starts to rise up. Around it, that air has also collected the moisture from past rainfall, from lakes, from seas, and that is being carried as the air as water vapour. And as it rises, it's going to continue doing so until it reaches the edge of our atmosphere, until it can't rise any further. So we're basically at the edge of space. It's quite cold now, so that warm air is going to start to cool. And just like a cold day in the house, we're going to start to develop condensation. So that water vapour that's being carried by the air is going to start to condense and form water droplets, which we know are clouds. And clouds bring rain. So at these low pressure points, this is where we're going to start finding cloud formation and rain. So while along the equator, it's going to be really hot, it's also going to be really wet with a lot of rain and cloud cover. As this cell is now at the edge of the atmosphere, it can't move any further out, so it's going to move either north or south. And we know it's getting colder, and cold air becomes more dense, so it's not going to stay up at the top of the atmosphere forever. Instead, once it gets too cold and too dense, it's going to start to descend. So these areas where the two blue arrows come together are high pressure. So heavier air sinking down back to the ground. Now, this air has already lost all its moisture at the high pressure where it started to rain. So the descending air is actually really dry, and you can see from the picture, no clouds. So this is the sort of weather we'd associate with our summertime, where we've got clear skies, warm weather, which sounds wrong, doesn't it? Because this is cold descending air, but there's no clouds to obscure the sun, so it means that it feels warmer to us, and there's very little wind. But it's not as clear cut as that. So we've talked about the incoming solar radiation along the equator, but it's not evenly distributed across the entire planet. We've already talked about how the equator gets the most intense. Let's have a look at further north. So this is the same amount of insolation. So the width of this bar is exactly the same as the width of this bar. At the equator, it's the same width on this side as it is on this side. So that's the same amount of sunlight or radiation warming up this area. However, the further north we go, you can see this edge is much longer than this side or this one here. So what's happening is the same amount of radiation has been spread over a greater distance. So if we look on the globe, it's going from here all the way up to there. So that means that this low pressure here is not going to be as intense because there's not as much heat warming up, or much radiation, warming up this area of the land as there is here. So at this point here, we call this the ITCZ, or the Intertropical Convergence Zone. So this is the part that receives the most insolation, heats up the ground the most, and so it gets the most intense rising of air, or the most intense low pressure. It's also called the Intertropical Convergence Zone because these little red arrows represent trade winds, the direction of the movement of air along our planet. And you can see that at the from the tropics moving towards the equator, we've got these winds moving towards each other, Intertropical Convergence Zone. That pretty much sums it up for our 5-minute lesson. You can stop going around in circles like that Hadley cell. Don't forget to complete the try it now tasks for homework. Class dismissed.